Welcome back to another video on mesh analysis. In last few videos, I had considered the different aspects of mesh analysis, but in all of them, we had considered only independent sources. This is going to be the last video on mesh analysis. In this case, I will consider dependent sources, that how to solve the problems when we have dependent sources present in the network. So what we need to do when we have a dependent source in the circuit, in that case, we need to write the equation of controlling quantity in terms of mesh currents. So let's consider different examples to understand that how to solve the problems using mesh analysis if we have any dependent source present in the network. First example which I am considering, a network is given to us in which we have a dependent source, then an independent source, 5-volt source, 5 ohm resistance. This one is also a voltage source, but this is a current dependent voltage source. In this branch, we have another current dependent voltage source which is supplying us voltage 2 into IY. So this is the given circuit. IX and IY, they are also given. This is a given network. And question is, find currents Ix and Iy using mesh analysis. This is a question. So we have 4 sources in total in this network. 2 are independent voltage sources while 2 are current dependent voltage sources. So as we have to apply mesh analysis, so for the first step is we have to identify that how many meshes are there. So we have 2 meshes. Second step is we need to assign current to each mesh. I'm assigning I1 to this mesh, I2 to this mesh, and I forgot to mention this resistance. This one is 1 ohm. So after assigning the mesh currents, first step is we need to express the controlling quantities. Now what are the controlling quantities? For this source, Ix is the controlling quantity, while for this source 2 into Iy is the controlling quantity. So it means we need to write Ix and Iy in terms of I1 and I2. So if you just look at this branch, current through 4 ohm resistance is Iy, and if I try to find out that which mesh current flows through the 4 ohm resistance, that is clearly I1. I1 is flowing through 4 ohm resistance. So it means I1 is same as Iy, or Iy is same as I1. And if we look for Ix, Ix is the current in this branch which is flowing in downward direction. So we want the resultant mesh current in downward direction. I1 is flowing in downward direction, I2 is flowing in upward direction. So what we get from here, that Ix is equals to I1 minus I2. Since I1 and Ix, they are in same direction, and I2 is just opposite to Ix, so Ix is equal to I1 minus I2. These are the two equations which we get by expressing the controlling quantities in terms of mesh currents. The next step is we have to apply KVL to each mesh. So I'm firstly applying KVL to mesh 1. I will start with this 5 volt source. Positive sign is coming first, so plus 5. Then drop across 5 ohm resistance. For 5 ohm resistance, drop is 5 into I1, since the current through 5 ohm resistance is I1. Then we have next source, which is supplying us voltage 2Ix. As positive sign came first, so I have written plus 2Ix. Then we have drop across 4 ohm resistance, plus 4 into I1. Next is a drop across 1 ohm resistance, plus 1 into I1 minus I2. Then we have voltage source 2Iy, and for the source, since the negative sign is coming first, so minus 2Iy equal to 0. Now we need to substitute the value of Ix and Iy in this equation. So 5 plus 5 I1 plus 2 into I1 minus I2 plus 4 I1 plus I1 minus I2 minus 2 I1 equal to 0. On simplifying, we get the equation as 10 I1 minus 3 I2 equal to minus 5. So this is our first equation. Second equation we will get by applying KVL to mesh 2. For that, let's assign the voltage drop polarity across each resistance which is appearing in mesh 2. As per the direction of current of I2, this terminal of 2 ohm resistance is positive, this one is negative. Then we have 10 volt source, 2I voltage source, and then drop across 1 ohm resistance. This terminal will be positive and this will be negative. Starting with 2 ohm resistance, by applying KVL to mesh 2, we will have 2 into I2, then we have 10 volt source, negative sign is coming first, minus 10. Then we have 2Iy source, positive sign is coming first, plus 2Iy. Then we have drop across 1 ohm resistance, plus 1 into I2 minus I1 equal to 0. Now substituting the value of Iy in this equation, 2I2 minus 10 plus 2 I1 plus I2 minus I1 equal to 0 will give us the equation as I1 plus 3I2 equal to 10. This is our second equation. Now when we solve these two equations, we will get the answer of I1 and I2. I1 is 0.455 ampere and I2 is 3.182 ampere. Now when we have the value of I1 and I2, we can get the value of Ix and Iy as well, as Ix is equals to I1 minus I2. We had already expressed this controlling quantity in terms of mesh currents, so it comes out to be minus 2.727 amperes, while Iy is same as I1, so it is 0.455 amperes. Let's take another example to understand mesh analysis. If we have a voltage dependent voltage source in the circuit, Question is find mesh currents in the given network. The given network is having different voltage sources we have two voltage sources, both are voltage dependent voltage sources. 5 volt source, 5 ohm resistance, 2 ohm plus 10 volt. So circuit is quite similar to what was there in the previous question. V1 is the voltage across 5 ohm resistance. Its polarity is already marked in the question. V2 is voltage across 2 ohm resistance. Its polarity is also marked. So this is the problem given to us, and we have to find out the mesh currents. First step is we need to identify how many meshes are there. It's very clear that we have just two meshes. Let's assign mesh current I1 to first mesh, I2 to second mesh. Then next step is we need to express the controlling quantities. Now what are the controlling quantities? V1 and V2. Since the output voltage of these two dependent sources is controlled by these two respective voltages, so these are the controlling quantities. We need to write the equations of V1 and V2 in terms of I1 and I2. So we just look at this. V1 is the voltage drop across 5 ohm resistance. Since this terminal is already marked as positive, this one is negative. So as per this polarity of voltage drop, current should be in downward direction. But our assumed direction of current is upward. So when we write the expression of V1, V1 is voltage drop across 5 ohm resistance. Since the current through 5 ohm resistance is I1, so it's 5 into I1. But the direction of current I1 is just opposite to what is the required direction of current as per the polarity of V1. So it is minus 5 into I1. Second is we need to write V2. V2 is voltage drop across 2 ohm resistance. As per the assigned polarity of V2, which is given to us in the problem, direction of current through 2 ohm resistance, it should be like this. I2 has same direction, so the value of V2 is 2 into I2. I hope it makes clear that why this V1 is equal to minus 5I1 when we write the equation of V2. In case of V2, the required direction of current and actual direction of mesh current, they are same, while in case of V1, the required direction of current through 5 ohm resistance is just opposite to the direction of mesh current. So we have a minus sign over here. So once we have the equation of two controlling quantities, next step is we have to apply KVL. Let's apply KVL to mesh 1. For mesh 1, I will start with the 5 volt source. Positive sign is coming first, plus 5. Then we have voltage drop V1. Negative sign is coming first, so minus V1. Then we have voltage drop. It is a drop because we are moving from positive to negative, plus 2V2. Then we have drop across 4 ohm resistance. So it will be 4 into I1. We need to mark the voltage polarity across this 1 ohm resistance as per the direction of current, which is in same direction with I1. So it will be plus I1 minus I2. Then we have next voltage source. Negative sign is coming first, so minus 2V1 equal to 0. Now substitute the value of V1 and V2 in this equation. So 5 plus 5I1 plus 2 into 2I2 plus 4I1 plus I1 minus I2 minus 2 into minus 5I1 equal to 0. Simplification of this will give us the equation 20I1 plus 3I2 equal to minus 5. This is the first equation. Second is apply KVL to mesh 2. Start for this from this 2 volt source, 2 ohm resistance. Voltage across this 2 ohm resistance is V2. Positive sign first, so plus V2. Then we have 10 volt source plus 10. Then we have this voltage source. Again positive sign is coming first, so plus 2 V1. Now we need to assign the voltage parity across this 1 ohm resistance as per the direction of I2. So this terminal will be positive and this will be negative. When we write the equation over here, it's plus 1 into I2 minus I1 equal to 0. Now let's substitute the value of V2 and V1 in this equation. V2 is 2I2 plus 10 plus 2 into minus 5I1 plus I2 minus I1 equal to 0. So this one is minus 11I1 plus 3I2 equal to minus 10 is second equation. So we have two equations, 1 and 2. When we solve these two equations simultaneously, we will get the answer of mesh currents I1 and I2. I1 is 0.161 ampere and I2 is minus 2.742 ampere. So when I2 is coming as minus 2.742, it means the assumed direction of mesh current is just opposite to its actual direction. So let's take one more example in which we will have both the current source and voltage sources. Question is, for this given network, we have to find out the mesh currents and power supplied by dependent voltage source. So let's draw the network first. This one is a voltage dependent voltage source, while this one is voltage dependent current source. This one is an independent current source across which voltage is V1, 20 ohm resistance, 30 ohm resistance and 50 ohm resistance. So in this case we have three meshes. Let's assign three different currents, I1, I2, I3. Now what we see in this problem, in first mesh we have a current source in the outer branch, so that will give us a direct answer of I1 as 5 ampere. Since I1 and 5 ampere, this will be the direction of I1, and 5 ampere, they are in same direction, so I1 is same as 5 ampere. If we look at in the second mesh, in second mesh, and we have another current source, it is a voltage dependent current source. It will supply point 1 V1 current in upward direction while I2 is in downward direction. So they are opposite. From mesh 2 we get I2 as minus 0.01 V1. So these are the two mesh currents which we get directly. Now what is this voltage V1? The controlling quantity, that is the voltage across 5 ampere source. In case if we don't know that what is the voltage across current source, then we are not able to apply KVL. But in this case, it's already mentioned in the problem that voltage across this 5 ampere source is V1. So we can easily apply KVL. So let's apply KVL to mesh 1. Start from this V1 minus V1. Then we have drop across 20 ohm resistance. Let's assign the drop polarity in direction of I1. So plus 20 into resultant current in direction of I1 is I1 minus I3. Then we have voltage source 0.4 V1. Positive sign is coming first. So plus 0.04 V1 equal to 0. When we substitute the value of I1 in this equation, so what we get? We will get the value of, we will get the simplified equation as 0.6 V1 plus 20 I3 equal to 100. This is the equation after using the value of I1 as 5 ampere. Next equation we will get by applying KVL to mesh 3. Now when we apply KVL to mesh 3, now again assign the voltage drop polarity as per the direction of I3. So I3 to 30 ohm is from right to left in this direction, plus minus, to 20 again in this direction, plus minus. So let's start with the 50 volt source, 50 ohm resistance, 50 into I3 plus 30 into I3 minus I2 plus 20 into I3 minus I1 equal to 0. So what we have? Minus 20 I1 minus 30 I2 plus 100 I3 equal to 0. And when we substitute the value of I1 in this equation, we will get minus 30 I2 plus 100 I3 equal to 100. So this is the second equation. So what we see that we have two equations. First one involving V1 and I3. Second one is involving I2 and I3, but we have three different variables. So what is the third equation? Third equation is from here, that I2 plus 0.0 V1 is equal to 0. This is a third equation which we actually got from mesh 2. So now we have three equations and three unknowns which will give us the value of V1 as 148.148 volts, I2 as minus 1.48 amperes, I3 as 0.56 amperes. So the question was we need to find out the mesh currents. So we got the answer of I1 in the very first step. I1 is 5 ampere, I2 is minus 1.48 and I3 is 0.56. And next part of the problem was we need to find out the power supplied by dependent voltage source. Now what is the power supplied by dependent voltage source? This is our dependent voltage source, 0.4 V1. Power will be 0.4 V1 into resultant current through this. So that will be I1 minus I2. So it will be equal to 0.4 V1 into I1 minus I2. 0.4 into 148.148 to 5 plus 1.48, which will give answer as 383.999 watt. This is the power supplied by the dependent voltage source. The last problem for the mesh analysis is the special case that when we have a current source common between two meshes. So it means that is the case of super mesh, but in this case we have a dependent current source common between two meshes. This is a current dependent current source. Ix is a controlling current. It is a current source since an arrow is marked inside the diamond shape. This source is supplying 52 volts, 8 ohm resistance, 50 volts. Ix is the current through this branch, and here we have another dependent source which is supplying voltage 5 Iy, and Iy is the current through 6 ohm resistance. So this is the given network, and question is find current through 8 ohm resistance using mesh analysis. So we need to assign mesh current to each mesh. Let's assign this current as I1, to this as I2, this mesh as I3. Now when we try to apply KVL to mesh 1, we can write the voltage as 50 volts. We can mark the polarity of voltage drop across 10 ohm resistance. We can write that value as well. But when we come across this 0.5 I1 current source, we don't know that what is the voltage across this. So we can't apply KVL. And same is the case when we move on to second mesh. We can write the voltage drop across 6 ohm resistance, across 8 ohm resistance, then voltage of 52 volt source. But we have no idea about the voltage across this 5ix source. So what we need to do, we need to combine these two meshes all together to make a super mesh. So what we have, combine mesh 1 and mesh 2, and that will give us super mesh. So in case of super mesh, what we will have one KVL equation, and second will be the constraint equation. So the KVL equation, I will start with this 50-volt source, minus 50 plus drop across this 10 ohm resistance plus 10 into I1 minus I3, then drop across 6 ohm resistance plus 6 into I2 minus I3, plus drop across 8 ohm resistance plus 8 I2 plus 52 equal to 0. So this will give us the equation as 10 I1 plus 14 I2 minus 16 I3 equal to minus 2. That is the first equation. Second is the constraint equation. Now the constraint imposed by this current source is that the resultant current through this branch should be in upward direction and it must have the value as 0.5 Ix. So the resultant current in terms of mesh currents in upward direction will be I2 minus I1, since I2 is in upward direction and I1 is in downward direction. This is the direction of I2 and this one is for I1. So constraint is I2 minus I1 is equals to 0.5 Ix. We need to express this Ix in terms of mesh currents. Ix is the current in this branch. So if we look at the direction of I1 in this mesh, it will be just opposite to this. So what we have, that Ix is equal to minus of I1. So when we use this value of Ix in this equation, so it will be I2 minus I1 is equals to 0.5 I1, which will give us equation minus 0.5 I1 plus I2 equal to 0. This will be the second equation. Third equation we will get from the third mesh. What we have in third mesh, we have a current dependent voltage source. Then 6 ohm resistance, we need to mark the polarity of voltage drop across 6 ohm resistance as per the direction of I3. So this terminal will be positive and this will be negative. For 10 ohm, positive, negative. So I will start with 5 IY source, mesh 3 plus 5 IY, then plus 6 into I3 minus I2, plus 6 into I3 minus I2. Then we have drop across 10 ohm resistance. Current in this direction is I3, in this one it's I1, so it's plus 10 into I3 minus I1, plus 10 into I3 minus I1 equal to 0. Now in this case we need the value of Iy as well. Iy is the current through 6 ohm resistance. It's flowing from left to right. I2 is in same direction with Iy, while I3 is in opposite direction. So Iy is equal to I2 minus I3. Iy is equals to I2 minus I3. Now substitute this value of Iy in mesh 3 equation. So we will have 6 into I3 minus I2 plus 10 I3 minus I1 equal to 0. So the simplification of this equation will be minus 10 I1 minus I2 plus 11 I3 equal to 0. So this is our third equation. Now we have three equations and three unknowns, 1, 2 and 3. When we solve these equations simultaneously, this will give us the value of phi1 as minus 1.158 ampere, I2 as minus 0.579 amperes, I3 as minus 1.105 ampere. Since all the currents are coming as negative, it means all the assumed directions are opposite to the actual direction, means actually all the mesh currents are flowing in clockwise direction. Now our question was we need to find out the current through 8 ohm resistance. So current through 8 ohm resistance, I 8 ohm, is 0.579 amperes and it's flowing in upward direction. I hope this video is helpful to you. In the next video, I will start with the another technique for analysis of networks known as nodal analysis.